This is an experimental feature that introduces flow affinity to the overlays. It changes the behavior of the system in such a way that what we call DPC, or the dynamic path selection, the mechanism that the EdgeConnect uses to pick which underlay it puts a particular packet, or in this regime, flow on. This is about changing the behavior of the EdgeConnect from per packet processing to per flow processing. Per flow handling improves throughput in a variety of different ways. If you put an EdgeConnect into, say, high throughput mode, and you have links that have different latencies, TCP doesn't behave well. It doesn't like the fact that you have per packet load balancing and that your SYN goes in one direction and your SYN-ACK and your ACK and your push go on different underlays. You get jitter, you get variable latencies, and per packet load balancing sounds good, but in practice, it does create some problems for TCP reliability and throughput. Let's talk about how we turn this thing on. It's been added to the QoS and WAN optimization section for the overlays, and it is a per overlay setting. When you select one of the waterfall modes, like high quality or high availability, you will see a drop down here, and it will say waterfall at some percentage. You can tell it what percentage you want it to waterfall at. At what point do you want to start loading flows onto the next best link? That is configured here. This is disabled by default, by the way, and when you mouse over this little eye thing, Flow Affinity causes flows to prefer the underlay on which the flow's first packet was assigned. First packet starts, we're going to pick an underlay, and we're going to stick to it. That's what this feature does in 9.6. The first underlay that's selected by whatever the mechanism is, that underlay will become the underlay that flow uses for the duration, or until the underlay becomes ineligible, at which point it will get moved, of course. So that has some implications. I'm going to run a CIFS transfer and measure the rate. That might not work as well, because just a single CIFS transfer, there'll just be one big fat flow. That single flow will not consume both underlays. The EdgeConnect is going to put the data path traffic on the primary link, and your FEC is going to go on the next best link. All that stuff remains the same. The difference is really more about how the bandwidth is utilized. I think that has more to do with like how we decide which flow gets bound to a particular underlay. Can you please show me which underlay a flow is on? Previously, we didn't know. So notice here on the left, when flow affinity is turned off, bonded tunnel. That's kind of all we can say, because who knows? It might be on MPLS, might be on INET-A, a little bit of both, neither, who knows? But in the flow affinity regime, it will tell you precisely which underlay it's on. So notice over here on the right, our flow affinity option here, disabled is the default for both upgrades as well as brand new deployments of 9.6 Orchestrator. This will be turned off. You can pick which one of these waterfall thresholds. We have 80% set. What will happen is that SCP client is going to communicate with that SCP server. Once INET-A reaches 80%, that flow can keep right on going and fill the rest of that link, but it can't spill over onto MPLS. That's it. That SCP client from port 1024 to port 22 on the SSH, that is stuck to INET-A. If it fills up, that's fine. But what happens is when the next flow gets ready to start, let's say another SCP client wants to talk to a different SCP server, or just another flow starts up, the algorithm will kick in. It'll say, look, the INET-A is already above 80%. So for this new flow that I'm about to start, I'm going to pick the next best link, which in this case is MPLS, 89 milliseconds, and it will assign that SCP flow to that underlay, to the MPLS underlay. So there's no per packet load balancing that ever happens here. That top flow is always going to be on INET-A, and the bottom flow is always going to be on MPLS. Now, high throughput mode wants to try to keep this white area the same. So now that's happened. These two devices have filled INET-A to the point that this is equal to that. What's going to happen next? Well, when a new flow starts, that new flow will start on MPLS because the INET-A one is already full. And of course, this guy can go ahead on and fill up that link if it wants to, but it's stuck to that INET-A. So even though we're in high throughput mode and we're doing link load balancing and stuff, the flows are going to have an affinity for and be stuck to a particular underlay. Now, this has a really good impact in that you're not going to get out of order packets. This particular flow here will have 86 milliseconds. This one will have 68 milliseconds. They'll be going across independent paths and they'll never touch each other. The main thing to consider with 960, though, is this warning says When a new flow starts, we pin it to an underlay, and it stays on that underlay forever. There's no rebalancing function. Once we decide on an underlay, if the underlay is healthy, that decision is forever. Let's look at the last one, link utilization. In this situation, all of these things work kind of the same way. Again, the algorithm wants to keep the percentage utilization the same on both links. And so once it gets there, it fills it up. But in every one of these situations, even in high efficiency, you don't ever have a per packet situation where a single socket is on two different underlays at the same time. It never happens.